Hey everybody, this is Larry. This is day 24 of the Leetcode May Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this daily problem. If I'm doing like weird pauses where I'm like swallowing a little bit, like this, it's because of allergies. I'm just kind of going a little bit nuts and kind of, yeah. I don't know why I'm still getting allergies. It's already almost June, but sometimes life is what it is. I think this is why I often, but not always, travel during this time. But as you can see, this year I have not. Anyway, let's take a look at today's problem. 1255. Maximum score words formed by letters. Given a list of words, list of single letters might be repeating, and score of every character. Return the maximum score of any rated set of words formed by using the given letters. Words about I cannot be used used two or more times, so it can only be used once. It is not necessary to use all the characters and letters, and each letter can only be used once. Score of letter A, B, C to Z is given by scores of 0 to 25 respectively. Oh man, just like really having a rough day, but okay. So basically you have these letters and you have these score and you have these words, right? What are we doing? And we're trying to figure out if we can do any words or any number of combination of words to maximize this, right? The key thing to note, and just taking a quick peek to be honest, and some of it is also, this is why like I'm a little bit sketch on how I feel about these themed weeks sometimes, because it's good to practice the same thing over a month or over a period of time. In this case, maybe a couple of days or almost a week or whatever. But then you do lose that ability of problem identification, right? Because okay, if I knew it was going to be enumeration or brute force, if you want to call it that way, then it really takes like a good chunk out of it, right? So it's a little bit unfortunate, but it is what it is. In either case, it is 14, so it should be good. I would also say that very often, but not always, because there are some inherent constraints sometimes. But very often, if you have these things where you have so many multiple choices for each thing, and you're trying to optimize some score, very often it is probably an NP. I don't know that this is always the case, because I feel like I'm also wrong a lot. And luckily in this case, I don't have to figure out because N is 14. But of course, if you're in an interview and they don't give you N or something, then having that knowledge would help, right? Yeah. But in any case, let's just do it then, right? So we have all these letters. We could just put them in a collection. So we have just count is equal to collection.counter of letters. Don't have to think about it too much. Score is from A to Z and words, right? So then now we just have to do a brute force thing, right? And I don't even know what we call it anymore. I just go because that's not even a name. That's just a word. Like get max maybe. I don't know. You have index for word, right? Oops. Index is for words. And then you have maybe a current collection counters, right? And I guess that's really it, I believe. You can map score into a hash table if you like, but it doesn't really matter. It shouldn't matter, right? So then now, and I don't really have that much new things to say, just because we have been doing the same thing for a couple of days. This is supposed to be a harder version, but I mean, everything else is just implementation after realizing that this is right. So yeah, if index is n, then we just return 0. Otherwise, we can, for each word we can skip or tick, right? So same. I mean, I've been using this terminology more and more. It's something that I just that I've been using for dynamic programming as well. And you do see, so once you kind of be able to kind of construct these in a good way. And the reason why you cannot dynamic programming though is that these are not states, right? Index can be a state, of course, but counts is not. Counts is basically a frequency table, and you have to kind of map that into a very distinct state, and they're just very like there's an exponential, maybe not exponential, but it's just, or you could count the number of states, right? The number of states is just the product of all the frequency counts, right? And if letters have 15 characters, then maybe you could say like 3 to the 4 or something like that, or 4 to the third or something like that. I don't know, 4 to the 4 maybe, which is 256 is actually not that bad. So maybe you can actually cache it if you really. Well, maybe you can cache it. I didn't realize that. Oh yeah. Oh no, I misread this one. Sorry. Score. Oh, score that length is 0 to 26. So maybe you can have something like 5 to the 5, which is I'm thinking on my calculator. Still 3,000. So I guess technically, probably you can actually cache on this. I was, but we don't have to. I guess at least until we're forced to. So let's take a look to see where it takes us. Okay, so skip is just easy, right? So then we have maybe best, we're maximizing, right? So best is equal to 0, best is equal to max, best get max, index plus 1, and we don't change counts. And then we take this word and we use it, so when we do this, plus the current score of this word, and we could actually pre-calculate this, and maybe we should. And maybe we'll just do like a get score of index, right? Let's just put it that way. And then here we got the score, and then we can update count. It's a little bit awkward, but no, you could do it in a funky way, which is that F for frequency table is equal to collections.counter of word sub index, and then if count is greater than or equal to F, then you could do this. Of course, this is a very Pythonic thing. Don't know what to make of it. I wonder if I could do this. Oops. I actually don't know, so we'll see if this is overloaded properly in the way that it is, and then we just return best. Anyway, yeah, and then we return get max 0 counts, and that should be in theory mostly the idea should be mostly right. Oh, I forgot to define get score, and the reason why I have I don't even need to write it this way. The reason why I got into a function is because so that we can memorize. So then you get best of both worlds, and I'm not going to go over memorization today, but basically adding this which is saying that this function, for every same input we get the same output, and by putting it in cache, then now we're just storing it at a place so that we get the same input again. We don't do the calculation again, right? And here I'm just going to be a little bit lazy, even though we did it twice, but we're only doing a constant number of times per index, so it's fine. And then for C for character, count, or V for value, I guess, which is kind of awkward. Score is, and this is I'm going to rename it scores. So yeah, score is equal to 0, right? And then we add it by score sub C, kind of, right? Times V, because that's the thing, and then we just return the score. So this is basically it. Of course, that's not quite it, because C is a character, and this is an array, so we have to convert it, which is something like that should be fine. And we're going to cache more stuff, but it's fine, huh? Non-iterable int object. F is equal to collections. What am I iterating on? Is this not right? I don't. Oh, not for that. It's items. I meant items. That's why it's a little bit awkward. Okay, looks okay now. So let's give it a quick submit. I don't know if this is right, only because I don't know all the libraries for this stuff. But let's give it a try. Yeah, okay. So that's what I expect that to do, which is actually pretty cool because I'm lazy. But yeah. So what is the complexity here, right? Well, in each call of this function, we branch twice. So that's going to be 2 to the n as a result. But each of these will also do a counter lookup thing. Maybe we can actually cache this as well, because then we'll use you know, something like this, right? So then now f is equal to get items, and then now we can actually replace this with get items as well. So then it uses the same thing, and we don't manipulate it, so it should be okay, right? Then, oh yeah, this is now a word, so of course this is. Did I do that? Yeah, I did that here too. Did I cache it? Keep in mind that it's a little bit slower, but whatever, because of the function call overheads, I suppose. But keeping in mind that this is this is taking advantage of the fact that we actually return a pointer, not a YU object or YU item or whatever, right? So if you are to manipulate the results that come from here, you have to be careful. Okay, it's just a very quick caveat in case, you know. But yeah, I don't know that I wrote this the cleanest or most optimized way, apparently, but that's okay. I think this is pretty clear and easy to read, even though maybe some of the overloaded function is not. But basically, for a counter, this just goes over for each key item, where it's a key item pairwise compare, right? And if it's greater than or equal to for every key, then we can do it, and subtract does the same thing, except for subtract on a item pairwise basis, and then we add that back as well. Yeah, so everything pretty Gucci. Yeah. So, and this is good, but it also makes this a little bit faster. So it's gonna be like 2 to the n times alpha or something like this, right? I guess. Yeah, I mean, the complexity is very kind of like, because there are a lot of things you can say also times L, because L is the size of the word, which is what this is bound by, and this is technically bound by the length of the word, and not the length of the word or the size of the alphabet. But in this case, the size of the alphabet is going to be 26, so it'll always be greater than the L. So anyway, that's all I have for this one. Let me know what you think. Thanks for watching. I'm going to do an extra problem after this. I think it's a hard one today, so we'll see. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.